Pi interfacing and programming with simulation, download ProTools 8.13 and free from the link in description box below. Then unzip and ordinarily install the .exe file on Windows OS, as shown in the ProTools icon appears on desktop screen. For installing the same on Raspberry Pi, first install Play on Linux. On terminal there, type sudo apt-get install Play on Linux and hit enter to install. Then install the same .exe file for ProTools there. But that is not recommended for slow running of the software due to configuration metric limitations. After installation, upgrade the software with Raspberry Pi 4 library, also available for download from the link in description box below. After downloading, just get to the two concerned files and copy them. Then go to C drive, then to Program Files x86, then to Lab Center Electronics, then to ProTools Professional, then to Data. Inside Data, there is Library. Just paste the copied files onto Library, and Present Upgrade is ready to use. Now on desktop, create a new folder for assigning as ProTools project path. Finally, open ProTools and click on New Project. Thereafter, browse and add the path to folder created earlier. Next, create schematic and PCB as you like. The creator of this video chose to create schematic without PCB layout. Choose Creating Firmware Project for interface programming. On successful creation of project, Resource Code tab opens first, but select the Schematic Capture tab to start with. Now on Schematic Capture work area, Raspberry Pi 0 schematic component is already present, as it was chosen at the time of firmware configuration on creation. Thereafter, for other required components, get them as shown from the library. Here, self-flashing yellow LED and our 1 resistor of 220 ohm are used for project demonstration. After getting all the parts, take them to the work area, possibly as close as possible to the center, by single left click on component names and double left click on the area where them are to be placed. Get the Raspberry Pi schematic board to the center by selecting in the blank and dragging the box. Then select the area of board schematic to select the board schematic for dragging it to desired place. Change direction of components by selecting them with left click followed by right click for options. required terminals of connections by single left click on the names followed by double left click on desired place in the work area. Here, default is selected for pin connection, power for power, and ground for ground. For drawing connections, single left click on one point, drag to the other point, and single left click there. Here the connection is shown from board power to board pin, from board pin to anode of LED, from cathode of LED to resistor, from resistor to board ground. After completion of schematic capture, interface programming is done on Resource Code tab. Alternatively, ready-made programming in any language may also be applied to the board by double left clicking on the board on schematic capture to assign the path to custom program in .hex file firmware format using Keel software, etc. if any other, for conversion. As far as writing source code for Raspberry Pi is concerned, ProTooth runs only board and BCM Python libraries, 4 board pin numbers and GPIO pin numbers respectively. Other Python libraries like GPIO 0 cannot be run as yet. Nevertheless, save the source code after writing and go back to Schematic Capture tab for simulation. Any error is shown in its log. simulate, press the play button at bottom left corner and see the electronics in virtual action. Go to Messages to get information about any error, if present. Electrical measurements can also be done on the circuit and components during simulation pause. If this video is found useful, please do like and subscribe for more of such videos in future. Thanks for watching.